Is Cosmos DB the best choice for your new project? Here's the truth that nobody's really talking about. Cosmos DB can be expensive. It can end up costing you more than you expect, but there's times when it's worth every penny. In this video, I'm going to break down the costs of Cosmos DB compared to Dynamo DB, MongoDB, some other solutions, and help you figure out exactly when it's worth it. Because sometimes the price is absolutely worth paying, and sometimes it's not. So I wrote this article about Cosmos DB. I'm going to take you through some of the high points of it and explain when it's useful. But yeah, first of all, what is Cosmos DB, right? Cosmos DB is Microsoft's high availability distributed database, first released as Document DB, and then rebranded to Cosmos DB in 2017. I kind of like the old name better. But it's used internally at Microsoft quite a bit. It's used for Bing. It's used for Office 365. It's available in all Azure regions. Basically, it's something that they take very seriously. So to understand when and why you might use Cosmos DB, you need to understand what it is. So I'm going to take you through a roadmap, right? We're going to compare it to a relational database, pros and cons, versus Mongo, which will help us talk about scaling and partitioning. Also, Cassandra is a great comparison case, so we can talk about consistency levels, and then we'll compare it to Dynamo and make some recommendations about when it's best to use it. Because I think if you understand all of these things, then you can understand if you're making a good decision. So as you know, there are a number of types of databases, right? There are relational databases. There are key value databases, document databases, NewSQL, which is really cool, like Google Spanner, CockroachDB. And then there's kind of what I'm going to call Dynamo inspired, these high write throughput, eventually consistent, globally scalable databases. It's important to understand what Cosmos DB is, because it can look like any of these if you squint, but it's not. The reason it can look like any of these is because of its architecture. It's a multi-model database in a very specific way in which you can speak to it using various languages, right? You can use SQL, you can use Mongo query language, you can use Cassandra query language, but no matter what you're using, you will end up talking to this document DB storage layer, right? So don't be confused by what it looks like. You need to pay attention to what it is. Also, it's very interesting that the most recommended API for talking to it, and the one I recommend you use, is the NoSQL Core API. You speak to the NoSQL API using SQL. And you'll see why it's called the NoSQL API. It's because of this, right? Because at the end of the day, Cosmos DB is a document database. You're storing records of like JSON documents on the disk. So even if you might use SQL, it's actually not a relational database. But yeah, here is a simple code example, right? Just in C#, you can see I can put together this customer record with customer ID 12345, and then I've also set up the customer ID as a partition key, which we'll get to later. And it can look like SQL because I can do this kind of select where customer equals 125. But if you actually go and look at the record as it's stored on disk in the Azure Data Explorer, it's just this JSON record, right? So there is no schema. There's no relational data here at all. So this is one of the most, if you come from a relational database world, this is one of the most important things to note, right? This is a document database. Don't let the SQL fool you. It is being stored like this, and that has all kinds of ramifications, right, that you need to understand, such as, right, joins and relationships are hard, right? This isn't a Postgres or SQL Server database. So you can't do complicated joins. You can't set up foreign keys. You can have transactions, but only within the scope of records. You can't have transactions across partition keys. Consistency works a little bit different. Most importantly, probably, there's no schema, right? If you've worked with document databases in the past, probably you get this. But if you're used to SQL Server or Postgres or whatever, this can bite you, right? You need to do all the migrations yourself. There's no schema enforcing all the records are the same. That can be a big maintenance challenge over time. Also, right, query optimization. In a relational database, there are query optimizers. There is indexing. Cosmos DB will auto-index all the fields, but that's an important difference. Also, cost structure. right? You set up a relational database on some server, it has a fixed cost. Cosmos DB is not like that. It's designed to scale. It has request units. So depending on how heavily you use it, the cost will increase, and actually it can scale up and down. So that's great, but something to be aware of. Yes, if you want a relational database, this is my first key. If you want a relational database, this is not the thing to use. It's just not. It's something else. Now, what that something else is, if you are familiar with document databases, you may be used to MongoDB, right? And if you come into this thinking of Cosmos DB as something like MongoDB, you're a lot closer to the truth, right? In fact, you can take your MongoDB code and just change the connection string, right? And using that API we showed at the top, this will just work. Most of the MongoDB MQL queries you're making will just work. And that's because, yeah, it is a document database underneath the covers. The big difference between MongoDB and Cosmos DB, if you want to compare the two, especially Mongo Atlas, has to do with partitions and sharding. So with MongoDB, you can shard. So you set up something to shard on. So customer ID that we used before, you could say, okay, I want to split data across customer IDs. I'm never going to need to join things from one customer to another. So we call that our shard, and we set some shard ranges. We say, this customer range from here to here goes shard 1, range here to here goes shard 2, shard 3, etc. If you set that up, then Mongo has this router. And when you make your queries, it's going to, use those ranges to decide where to send things. And it can rebalance things as you scale these up. It can readjust, but it's basically a sharding approach. Cosmos takes this a bit further, right? They use, instead of what they call sharding, they use logical partitions. So yes, we are going to split things by customer ID. So each number of records associated with a certain customer ID is a logical partition, right? And so you can do anything within a logical partition that you would expect, but doing things across partitions is going to be very expensive. Now, behind the scenes, in a way that you cannot see, Cosmos DB has physical partitions, which are actually the server instances, and it just handles this, right? So based on access patterns of these logical partitions, it can decide how many should be grouped together on physical partitions. Maybe you have a whole bunch that are rarely used, and we can put them all together, and one that is very load heavy, and it can get scaled up into its own separate instance. But you'll have no way of knowing, because the physical partitions are not a thing you manage. You just manage the logical partitions. So it's a bit more hands-off, right? I think this may be a great reason that you would choose Cosmos DB, is you're using Mongo, or you understand document database, how to work with them, and you just want something that has a bit more hands-off scaling. It's a bit more operationally simple as you go up or down in size. Now, the way I think about all this, right, is if you understand the type of database you're dealing with, as I said, they all have trade-offs, and that helps you know when Cosmos is a good fit versus something else. And all this talk of like logical and physical partitions, what it brings to mind for me is Apache Cassandra, right? Apache Cassandra uses this consistent hashing algorithm, which is usually represented as a ring. Here's my little diagram here. And so you set up a partition key for your data, and when a request comes in, it maps these to a ring, and then ranges of the ring are assigned to nodes. And so as you add a new node, it can scale up or down and rebalance itself, right? So it is a way to scale up or down, and the requester just has to know about the logical partition, and the consistent hashing handles how to distribute that. How does Cassandra compare to Cosmos DB? Well, there's some ways that they're similar, right? The partitioning, as I mentioned, that seems similar, right? They both have this idea of setting a partition and then leaving it to a hashing algorithm to distribute the load. They both have tunable consistency, right? So in both Cassandra and Cosmos DB, on the request level, you can specify a level of consistency that you'd like. Usually you're doing sort of a eventually consistent, but you can set higher consistency levels. One of the differences between the two, right, is Cosmos DB has a session level consistency that lets you read your writes, but is less expensive than some of the other higher consistency levels. So key differences, right? Like you actually can use CQL to talk to Cosmos DB, just like with Mongo, but maybe not the best idea. And then operational complexity, I think is one of the very big differences, right? I used to work at a place that had a very large Cassandra cluster, and that, was the full-time job of like a team to keep it going with all the heavy write throughput that was happening. Probably they would have a lot less concerns if they were using Cosmos DB. Perhaps it would cost as much or more than that team costs and salaries. It's hard to say without specifics. But this is the big trade-off between the two, right? Apache, Cassandra, you are operating this thing. Cosmos DB, you are not. So here's an example, right? I could just take, in theory, my existing Cassandra code and change the contact point, as they call it, to be a connection string I can get from Azure. And in theory, this will work. Right, here's my CQL that looks a lot like SQL, actually. It looks exactly like SQL to me. But yeah, that'll work. And then the next thing to think about, right, in my mind, is Dynamo DB. Dynamo DB, based on the Dynamo paper that came out of Amazon, that also Cassandra was based on. The difference between the two, in a big way, is that DynamoDB is a managed service, right? They are taking away a lot of that work of running some sort of database cluster. You can just provision something and write to it and not worry about it too much, which sounds a lot like what we're saying here with Cosmos, right? So what are the differences between Dynamo and Cosmos? I mean, one of the big differences, one is like Azure and one is AWS, right? So if you are on Azure and you need to have a document DB with a high write throughput with varying consistency levels, with possibly distributing around the world, and in the past you would use DynamoDB, Cosmos DB is probably what you want, right? Which, like, to bring it all around to just like pros and cons overall, right? Cosmos DB, you want to use it when you need this scale, right? When you need this flexibility of schema, and when these consistency levels that you can set per query are useful, right? You mainly are doing eventual consistency, but maybe some things you need higher levels of consistency. Maybe you need to fine tune that. So those are all pros, right? And the biggest pro is this operational simplicity, that you don't need to do too much to scale up or down. But the big con of that, right, is cost. Like as you scale, it's just going to cost more. Another con that I didn't touch as much on is like tooling, right? If you're used to all the tooling you can get, monitoring, etc., on your existing like relational database, maybe that's a little bit harder with Cosmos because it's a specific thing and it's a bit newer. Also vendor lock-in, right? Like Cosmos DB is only ever going to be on Azure, so there you go. I mean, you could use the MongoDB API, but not every feature works the same. And it's not super clear if you move a workload from Cosmos to Mongo that it's going to be 100% the same. So you're probably locked in. So yeah, that is why you should use Cosmos DB. You should use it because you need something more than a relational database can provide. You want to not worry about scaling. You want to not worry about running a cluster, and you're willing to pay. If that's the case and you understand what you're doing, totally worth it, right? Lots of people use it as a great solution and they're very happy. If you're interested in exploring more about cloud infrastructure and modern infrastructure as code practices, you'll notice my Pulumi shirt. Be sure to subscribe to the channel and check out some of the tutorials I'll link to. I'll show you how to set up Cosmos DB. We have a great tutorial on that. Check out the link in the description to just head right to Pulumi, because Pulumi lets you use familiar programming languages to manage and deploy your cloud resources. Obviously, it can handle Cosmos DB and also Cassandra, and DynamoDB, and etc. And thank you for watching the video, and I'll see you in the next one.